if z is equal to 3 minus I, express z over z bar in the form a plus bi. So z over z bar is going to be 3 minus I, and then the conjugate of z means that the real part has the same sign, but we change the sign on the imaginary part. Now we want to realize the denominator, and we make use of the difference of two squares to do that. So multiply top and bottom by 3 minus I. So on the bottom here we've got 3 plus I, 3 minus I. Expanding the top gives us 9 minus 3I minus 3I plus I squared. Expanding the bottom, remember the cross terms will disappear. We get 9 take away I squared. Now I squared is negative 1, so we've got 9 take away 1 is 8 minus 6I, and on the bottom that's 9 take away negative 1, so that's going to be 10. So we get 8 tenths take away 6 tenths I. We want to determine the complex number z if 2z bar minus iz plus 4 plus I is 0. So let z be equal to x plus iy. Then we know that z bar will be x minus iy, and substitute this in. So we've got twice x minus iy, take away I, x plus iy, plus 4 plus I is equal to 0. Expanding out, that's 2x plus 2yi, take away ix, take away I squared y, but I squared is negative 1, so that's going to become plus y, is equal to negative 4 take away I. So collecting the real parts here, we have 2x plus y. Collecting the imaginary parts, we have, just noticed a mistake in the line above. When we expanded that one there, that should be minus 2yi. So we have I into minus 2y take away x. And that's going to be negative 4 take I. So equating the real parts gives us that 2x plus y is negative 4, and equating the imaginary parts gives us 2y plus x is equal to 1. We'd have negative 2y take away x is negative 1, so I've just multiplied through by negative 1. And now we have simultaneous equations. So multiplying the first one by 2 gives me 4x plus 2y is negative 8, and the second one is x plus 2y is equal to 1. So if we subtract, we get that 3x equals negative 9, and therefore x equals negative 3. Substitute that to here, and we'd get 2y take away 3 is 1, so 2y is 4, giving us y is 2. And therefore z is the complex number, negative 3 plus 2i. The complex numbers z1 and z2 are defined as z1 is 2 minus 2i, and z2 is 1 plus 4i. We want to sketch negative z1 and Z2 bar on the Argand diagram below. So if Z1 is 2 minus 2i, then negative Z1 is negative 2 add 2i. So we go to negative 2, 2, and you only really need the point, but I usually put them in as vectors. And so this is negative Z1. And then Z2 is 1 plus 4i. So the conjugate is going to be 1 minus 4i. So 1, negative 4. So that will be down here. And that's Z2 bar. By displaying the complex numbers as vectors, demonstrate Z1 plus Z2 on the diagram below. So let's start with Z1, and we'll start that one from the origin. So that's 2 minus 2i. So that's going to go just here, and we'll label that one as Z1. And then we're going to add Z2, so we need to start Z2 here. Z2 is 1, add 4i, so that's going to take us up to there, like so. So that's Z2, and then that means that the third side of the triangle here is Z1 plus Z2. Now we can always check that. Where's it taken us to? It's taken us to 3 plus 2i. So if we do 2 take away 2i, and we add to that 1 plus 4i, we can see that is 3 plus 2i. So we know that this diagram is correct.